Hello everyone, welcome to Meritnation YouTube live session. So student, this is our second session of Wave. So in this session, basically we'll discuss a few numericals. So now we can start. Hello Arindam, hi Meghna. Good evening to all of you, beta. So now, so let's start now. Hello Khaira. So now we can start this session. So you can see on your screen the first question. Hi Shreya. So guys, in first question, you can see the number of possible natural oscillations of air column in a pipe closed at one end of length 85 centimeter, whose frequencies lie below 1250 hertz R. Okay, so we need to calculate here the number of possible natural oscillations. Okay, that's great, Arindam. So now we can start doing this question. So first of all, let me give you the idea about the closed organ pipe. Actually, in last class, I think we did few questions based on closed organ pipe as well as open organ pipe. So let's see here, student. First, let's find out the fundamental frequency for closed organ pipe. So student, suppose this is closed organ pipe. So here we can see the minimum possible stationary wave here is what? This will be the possibility, na? The first stationary wave. You can see this one. Okay, and suppose student, if the length of this tube is L, suppose here length of this tube is L. See, length of tube is L. So what about the length of this wave? Okay, this stationary wave. So we can say that is lambda by 4. Okay, so we can calculate here the value of lambda wavelength in terms of length. This implies lambda is equals to 4 into L. Okay, lambda is equal to 4 into L. So students, now you know the relation between the frequency and the wavelength and speed. So see, c is equals to mu by lambda, or I can say v is equals to mu by lambda. V is speed, okay, frequency and lambda. So here frequency is equals to v by lambda. Okay, so now what is lambda here? You can see lambda is 4 times of L, that is length of the tube here. So this is v by 4L. Okay, this is frequency. This is frequency. So students, you know very well this frequency is known as what? Fundamental frequency. Fundamental frequency. And you also know that, student, if we talk about the closed organ pipe, so beta closed organ pipe will get only odd harmonics. Here we'll get only odd harmonics. So see, we'll get only odd harmonics. Odd harmonics in closed organ pipe. So students, odd harmonic means what? That will be, see here, uh, fundamental frequency, suppose f naught, or you can f naught. So next will be 3f naught, third harmonic. Now fifth harmonic, seventh harmonic, okay, ninth, 11th, so on. Okay, here f naught is what? F naught is fundamental frequency. That is fundamental frequency. So students, and we have already calculated here fundamental frequency is what? V by 4L. So F naught is equal to V by 4L. So let us calculate the value of V by 4L. So student, here V is already mentioned in this question. You can see, let me show you. You can see 340 velocity of sound. Okay, V is equals to 340. And length of the tube is also given here. L is what? L is the length of the tube. So students, length of the tube is what? 85 centimeter. But we need to take here in terms of SI unit, that is meter. So let us take here. So students, 85 centimeter, or I can say that 0.85 meter, or simply we can also take here 85 by 100. We can take any one of them. Okay, so this is what? 340 into 100 divided by what? 4 into 85. So students, what about 100 by 4? So you can see simply here, this is 25 now. Now this, I think after solving, we are getting here 100. Please cross check. So student, here fundamental frequency is 100. Okay, so now fundamental frequency is 100. That's great, good, awesome. So we got here the value of f naught 100. Okay, now next thing, So students, this is 100 hertz. What about third harmonic? What about third harmonic? That will be 300. For this one, I can say 500. This is 700. Okay, 900. Next will be what here? 1100. And after that, 13 F naught. So that will be 1300. But student, we need to take only those possible natural oscillation which lies below 1250 hertz. Okay, so if we'll talk about the 13 F naught, 13 F naught will be equal to what? 1300 hertz. That is more than that of 1250. Na? It means the number of possible natural oscillations of air column is what? I can say 1, 2, 3, 4, 5, and 6. So six possible natural oscillations for above numerical. So here correct answer is what? D. I hope you understood. So here correct answer is what, students? 6. It means here option D is absolutely correct. And student, same question is also asked in JE paper as well, and data is also same. In that question you can see the same data. Okay, so this question is copied from JE. Okay, JE objective paper. Okay, so I hope you understood. Have you got the idea about this entire numerical? Have you got the feel of this numerical? Is that clear to you, students? So we need to know only a few points regarding closed organ pipe. The first point you can see, fundamental frequency for closed organ pipe is what? V by 4L. V is what? Velocity of sound. L is length of the tube. And the second point is what? Student, in closed organ pipe will get only odd harmonics. It means if fundamental frequency is F naught, next will be 3 F naught, 5 F naught, 7 F naught, 9 F naught, 11 F naught, so on. Okay, odd harmonics. Okay, so now move on to the next question. So you can see on your screen. So this question is entirely based on Doppler's effect. In last class, we did few questions based on Doppler's effect as well. And I also gave you the idea about the Doppler's effect in the first session of wave. So here you can see, student, a speeding motorcyclist sees traffic jam ahead of him. He slows down to 36 kilometer per hour. He finds that traffic has eased and a car moving ahead of him at 18 kilometer per hour is honking at a frequency of 1392 hertz. Then, if the speed of the sound is 343 meter per second, then the frequency of the hook, then the frequency of the horn, I can say that as hears by him, will be what? Okay, so students, simply this is, we can say here, horn as heard by him will be what? Okay, so students, how can we do that? How can we solve this numerical? So you know that the basic formula for Doppler's effect, student, apparent frequency. See, if we'll talk about the apparent frequency F dash, that is equals to F, okay, V plus minus V naught divided by V plus minus Vs is what? Okay, this is what? This is the formula for apparent frequency. So student, this is apparent frequency, I can say that apparent frequency. And what about this one? This one is actual frequency, no? Actual frequency. Okay, and what about this one? You know that velocity of observer, and this is what? Velocity of source. Okay, and you know that V is what? Velocity of sound, velocity of. Okay, so students, now let me tell you the way which we can use this formula. Student, first of all, suppose first vehicle is moving with a speed of what? 36 kilometer per hour, na? And this one is moving with a speed of what? 18 kilometer per hour. But, and you know, students, you know very well how can we convert a kilometer per hour into meter per second? You know the way? Kilometer per hour into meter per second by simply multiplying 15 by 18, na? By simply multiplying 15 by 18 meter, 15 by 18. Suppose here 36 kilometer is given us, so 36 into 5 by 18, that is 10 meter per second. Simply for 18, you can see 18 into 5 by 18. See what we are getting here? 5 meter per second. So I can say that this vehicle is moving with a speed of what? With a speed of 5 meter per second, and this one is moving with a speed of what? 10 meter per second. Okay, so students, now according to above question, this car is making this is producing a sound of frequency 1392 hertz. Okay, producing sound. So I can say that this is acting like a source. This is acting like a source because that is producing sound. No, okay, and this one is acting like a observer. Okay, acting like a observer. So students, now you know the way I gave you the way, I gave you the method which we can use to apply this formula in this numerical, in these kind of numericals. So again, I'm repeating the same thing here. So see, you can see here f dash is equals to f. Now student, here you can see according to formula, this is v plus minus v naught. Okay, v plus minus v naught divided by v plus minus vs. So we need to check whether we need to take here positive and negative sign. So students, see, f is what? F is the actual frequency, that is 1392. Okay, v is what? V is a velocity of sound. So student, first of all, you can see if we'll talk about the observer, guys, observer is moving towards the source. No? See, this is the source and this is the observer. So observer is moving towards the source. So obviously, if it is moving towards the source, so in that case we need to take here this one as a positive. We need to take the maximum value. Okay, we need to take here the maximum value. How can we take numerator to get the maximum value? And that is only possible when we'll take here v plus v naught. If we'll take v minus v naught, that will be minimum, but if we'll take v plus v naught, it means we are getting here maximum. Okay, that's why. Now let's talk about the source. So student, now if we'll talk about the source, so you can see student, source is moving away from the observer. Source क्या है? Observer से दूर भाग रहा है. See, this is the source na, and that is moving away from the observer. Sorry, away from the observer. So source is trying to decrease the frequency, guys. Source is trying to decrease the frequency. That is only possible when we'll take here the maximum value. Okay, he is source is trying to decrease the value. Okay, and how can we use this formula? V minus v plus v naught. Sorry, v plus vs. Okay, we need to take here the maximum value because your source is moving away. Na? That is increasing the separation between O and S, or I can say the way I can say this is what? This is trying to decrease the frequency. So that is only possible when we'll take the maximum value here. Okay, maximum value of denominator. It means V plus Vs. Okay, and if we'll talk about the observer, observer is trying to increase the frequency. So for that we need to take here the maximum value of numerator, and that is only possible when we'll take here V plus V naught. Okay, that's it. Now just put the value of V and V naught and Vs, you will get the final answer. So let's see here student, so this is what, 1392. I think here V is given, velocity of sound, that is 343. You can see 343. What about V naught here? Yeah, this is V naught now. So this is 10. Now 343. What about the source? For source 5. That's fine. So I think after solving you will get 14 12 hertz. Okay, so I think this is the correct answer. So I hope you understood. So any issue, anyone of you in this numerical? I hope you understood. Have you got the feel of this numerical? Simple, extremely simple for you guys. You can easily deal with these kind of questions, or you can say questions based on Doppler's effect. You can easily do that, and you can also solve those questions that is entirely based on open organ pipe, or you can say closed tube, open tube. Okay, so now let's talk about the next question. So see, let's talk about the next question. So here you can see on your screen, student, a wave traveling in positive direction having displacement along y direction as 1 meter. Okay, that's fine, that's great. And wavelength 2 pi meter and frequency of 1 by pi hertz. Okay, is represented by what? So basically in this question we need to find out the equation. Okay, we have to find out the equation of the wave which is traveling in positive x direction. Okay, and displacement of the particles along y direction is given 1 meter. Okay, displacement is given in y direction 1 meter, and the wavelength is given 2 pi meter, and frequency is also given. So we need to find out the equation. So student, you know very well, suppose if we talk about this wave, suppose this is the wave which is traveling in positive x-axis. Suppose this is the wave. Okay, so student, for this wave equation is what? Y is equals to a sine omega t minus kx. Okay, so simply to find out the equation of this wave, we need to find out the value of a, omega, and k. Okay, that's it. So students, if we'll talk about the a here, a is what? Maximum displacement. A is what? Amplitude. amplitude, and in this question you can see amplitude is given what, here you can see 1 meter. Okay, that is what displacement along y direction, that is 1 meter. So simply we can write here amplitude 1. So here a is equal to 1 meter, we got here the value of a. Now let's talk about the omega. So you know omega is what, 2 pi f. In this question frequency is already given, you see 1 by pi hertz. So that is already given here. So now this is 2 pi and frequency is what, 1 by pi. Now we can use our weapon, you know that discount. So what we are getting here, students, omega is equals to 2. Okay, 2, or I can say 2 radian per second. This is what, this is omega. Okay, so we got here the value of omega. Now that's fine. Now we need to find out the value of k. And students, the formula of k is what, k is equals to 2 pi upon lambda. 2 pi upon lambda. So students, 2 pi. Okay, 2 pi. And if we'll talk about the lambda, so lambda is given here, wavelength is given 2 pi meters. So just put here the value of 2 lambda here. So see, so we are getting here 1. Okay, so the value of k is 1. So student, we have calculated here the value of a, omega and k. Just put these values in this equation. That will be the equation of our wave. So let's do that. So students, y, a is 1 sine omega 2 here. Okay, 2t minus k is 1. This. So this is our equation. Y is equals to sine 2t minus x. Okay, so this is the answer. Y is equals to sine 2t minus x. Okay, so which of the option is correct here? So I think if we talk about the options, so you can simply see here, student, option A is the answer. Okay, you can think about, you can reverse the negative sign as well. Okay, so I hope you understood. So any issue, anyone of you in this equation, in this numerical, any problem? Clear? Okay, so now this one is our last question, not last one, second last. So guys, you can try, I'm giving you hint. Two sources of sound placed close to each other are emitting progressive waves given by y1 and y2. So equation is given here. Okay, and basically we need to find out the beats. Okay, and the ratio of the intensity. Okay, we have to find out the number of beats, or you can say beats. Okay, and intensity. So how can we do that? Come on, let's see. Let us discuss this question. So student, here y1 is given. See, y1 is 4 sine 600 pi t. Okay, this is y1. Okay, this is y1. And student, what about y2? See, if we'll talk about y2, so y2 is equal to, y2 is equals to 5 sine 608 pi t. Okay, two equations now. That's great. So student, now what we need to do here, we need to find out the first frequency. First frequency we need to find out. So here you can see this is omega na. So here omega is what, 600 pi, omega 1 I can say. And here omega 2 is what, omega 2 is 608 pi. So students, omega 1 is what, 2 pi f1. Okay, so here 2 pi f1 and omega 1 is already given in here 600 pi. 600 pi. So students, now you can see again we can use our weapon. So discount. So f1 is 300 hertz. Okay, so this is 300 hertz. What about this one? What about this one? You can see omega 2 is 608 pi. Okay, that's great. So omega 2 is what, 2 pi f2. So 608 pi. Again we can use our weapon. So now let's see here. So discount. So I think this is 304 hertz. Okay, so we have calculated here f1 and f2. That's great. F1 and F2. So student, how can you find out the beats? You can see we have to find, because you can see in these options you can see beats and the intensity ratio. So let's see here. So let's talk about the beats. So you know the, that is what, that is mod f1 minus f2. Okay, it means I can say 300 minus 304. So that is 4 beats per second. Okay, so here number of beats I can say that 4. Okay, that is what, that is the difference of frequency, no? So 300 minus 304 will get negative, but we are using here mod. You can see this is what mod. So we need only positive value. Okay, we need only magnitude, and we are getting here 4. So 4 beats per second. So I can see in the only first and last option we are getting 4. Okay, so it means we need to also think about the intensity, ratio of intensity. So let's do that. So we need to find out the intensity. So students, I1 by I2. Okay, that's nice. That's great. So student, we're talking about the intensity. So I1 by I2, how can we find out? How can we find out the ratio of intensity? So student, any idea, any one of you? How can we calculate the intensity ratio between waxing and waning? It means we need to calculate here I1 and I2, I1 and I2 for maxima and minima. Okay, not for maxima. You can say maximum intensity to minimum intensity. So, A1 plus A2 whole square. Yeah. And this is A1 minus A2 whole square, student. Okay, maximum to minimum. Okay. So, student, here A1 is what? You can see here, this is A1. Just a second. This is A1. Amplitude, amplitude of first wave A1, amplitude of second wave A2. So 4 and 5. Okay, 4 and 5. So students, see, this is 4 plus 5 whole square, and this is, I can say, 4 minus 5 whole square. So I think we are getting here 81 by 5. Okay, students, please try to focus here on these words. You can see these, waxing and waning. So it means we need to find out the ratio of maximum intensity to minimum intensity. Okay, and according to this question, two sources of sound placed close to each other emitting these waves. Okay, so guys, when these waves superimposed, no, so then what we'll get? Then we'll get a new wave. So we need to find out the ratio of the maxima to minimum intensity of that wave. Okay, so that is I1 by I2 here. Okay, so what we are getting here, that is 81 by 1. So here the correct answer is what? Option T. Okay, so here student, beats 4 beats per second and the intensity ratio 81 by 1. This is the solution of this numerical. Okay, so now let's talk about the last question of today's session. So in that question, student, that is you can say that is based on what? Phase difference. Basically we need to find out the phase difference between two waves. So student, you can say CBSE AI Primary 2011. So you can see Y1 is given A sine omega t plus kx. Okay, plus kx 0.57. Okay, that's great. Okay, this equation is given in terms of sine. Now what about the second one? Y2 is equals to A cos. Okay, A cos omega t plus kx. So student, we can't even think about phase difference, because here you can see first equation is in terms of sine and second one is a function of cos. So we can't solve this question without converting either sine into cos or cos into sine. Okay, both equation either should be in sine or cos. So let us convert y2. Y2 is given here in terms of cos. No? So let us convert y2 in terms of sine. And how can we do that? We know very well, student, cos sine 90 by 90 plus theta is what? Cos theta. Sine 90 plus theta is what? Cos theta. So what we can do here? See, this is we can do this thing. Suppose this can be done as y2 is equals to a sine pi by 2 plus omega t plus kx. Okay, omega t plus kx. So now you can see this is what? Sine 90 plus theta. Na? This is 90, you can see. And this entire value is acting like a theta. So sine 90 plus theta is what? Cos theta. It means cos omega t plus kx. Okay, so this is our second equation. Now we can find out the phase difference y1 and y2, because now y1 is also in terms of sine and y2 is also in terms of what? I can see sine. Now we can find out the phase difference. So here you can see this is what? Omega t. Okay, fine, this is also omega t, and rest of the part is what? Angle. Rest of the part is suppose angle. Okay, so student, so here you can see this is what? Kx plus 0.57 and here 90 plus kx. Okay, so let's see here. Let's find out the phase difference. So phase difference, suppose student, from this question you can see that phi 2 is what? Phi 2 is, I can say that 90 plus, or I can say pi by 2. Okay, that's fine. We can take here pi by 2. So students, pi by 2 plus kx, and here what about phase difference? What about phi 1? What about phi 1? We can get from the first equation. See, from first equation phi 1, that is I can say kx plus 0.57. Okay, fine. So now we need to find out delta phi phase difference. So that will be equal to what? Phi 2 minus phi 1. No? Just put the value of phi 2 and phi 1 here. So pi by 2 plus kx minus, okay, minus, and you can see here kx plus 0.57. Now we can change the sign. So this is pi by 2 plus kx minus kx minus 0.57. Now again we can use our weapon. So students, so discount what we are getting here, pi by 2 minus 0.57, student. Okay, and we know that the value of pi is what, 314, no? So 314 divided by 2 minus 0.57. So I think we are getting here 1.57 minus 0.57. So finally we are getting here a 1 radian. Okay, so here the phase difference between y1 and y2 is what, 1 radian. Okay, so which of the option is correct here? So I think option D is absolutely correct. So you can see here, beta, this question is entirely based on what, the phase difference. First, both equations should be either in terms of sine or cosine. Okay, then we can you apply this formula, delta phi is equals to phi 2 minus phi 1, and after doing the calculation we'll get the phase difference. Okay, so now we can end this session. So thank you so much everyone. This is the end of the waves. Thank you so much everyone. Thank you.